Decoded.
Welcome back to Book Decoded.
Great to be here.
Today we're cracking open Artificial Intelligence and Biological Sciences, edited by P.V. Mohanan.
Yeah, a really interesting collection.
Our goal today is, well, to unpack how AI is doing more than just helping in biology and health. It seems like it's fundamentally changing how we even think about these fields.
Absolutely. It's a paradigm shift, really.
And it's wild to think John McCarthy coined artificial intelligence way back in '56, defining it as the science and engineering of making intelligent machines. We've certainly come a long way since then.
We really have.
So the book points out that a lot of the AI we're currently using, especially in these areas, falls under artificial narrow intelligence, ANI.
That's right, ANI. These are systems that are brilliant, but, brilliant at very specific tasks, like self-driving cars, for instance.
Okay, so narrow focus, but deep capability within that focus.
Exactly. And that narrow focus is actually their strength in fields like healthcare. It allows for incredible precision and speed.
How so? What's the big transformation there?
Well, take drug discovery. These AIs can sift through, just vast amounts of chemical data, looking for potential compounds, stuff humans just couldn't process on that scale.
So it expands the search space, essentially.
Massively. It's redefining the scope of discovery. We're finding new drug candidates faster and even finding new uses for old drugs. It saves huge amounts of time and, frankly, money.
That efficiency must be game-changing. And does this tie into personalized medicine, too? The idea of AI tailoring treatments.
Oh, absolutely. That's a huge area. Imagine an AI looking at your specific genetic makeup, your health history, and helping design a treatment plan just for you.
Optimizing outcomes, minimizing side effects.
Precisely. It fosters a sort of partnership between the doctor, the patient, and the AI's analytical power.
And beyond treatment planning, what about diagnostics?
Another major impact. AI algorithms are getting incredibly good at analyzing medical images.
Like spotting things humans might miss.
Exactly.
Yeah.
Subtle signs of early breast cancer on a mammogram, or maybe early indicators of Alzheimer's on an MRI scan. They can pick up patterns sometimes too subtle for our eyes.
That's remarkable, but I've heard the term black box used.
Ah, yes. That's a valid point the book raises. Sometimes, even though the AI gets the right answer, its reasoning, the steps it took, can be opaque. Hard for us to follow.
Which is a challenge, especially in medicine.
It is. Transparency is important, though its capabilities were still vital during, say, the COVID-19 pandemic, helping predict potential drug treatments and track the spread.
So it's useful even with that limitation. The book also mentions AI assisting in robotic surgery.
Yes, by creating these super detailed 3D models of a patient's anatomy. Surgeons can use these for really precise planning before an operation.
And what about this organ-on-a-chip technology? That sounds fascinating.
It really is. It involves creating tiny, miniaturized human organ systems on microchips.
Like little test beds.
Sort of, yes. They mimic how human organs respond.
Yeah.
AI comes in by enabling high-throughput screening, testing thousands of compounds on these chips very quickly.
Wow.
And predictive modeling, too. The AI analyzes the results and predicts how a drug might actually behave in a full human system. It's a big step beyond traditional lab tests.
Incredible research potential. Does the book look beyond the clinic into broader biological sciences?
Oh, yes, definitely. It's not just medicine. Think about genomics. AI is accelerating how we analyze genetic data to understand diseases at the molecular level.
Okay.
Or even in agriculture, optimizing crop yield by analyzing environmental data, soil conditions, genetic factors. It's about using data to unlock biological secrets across the board.
It all sounds incredibly powerful, which brings up the obvious question. What can it do? Where do we still need the human touch?
And that's crucial. The book is very clear on this. AI, for all its analytical power, cannot replicate human empathy. Compassion. That connection is irreplaceable, especially in patient care.
So it's not AI versus humans?
Not at all. It's a partnership. AI brings the analytical muscle, the speed, the ability to handle complexity. We bring creativity, ethical judgment, critical thinking, and that vital human connection. They complement each other.
But it's a partnership we need to manage carefully, right? The book mentions challenges like data bias.
A very important point. Yes. AI systems learn from data, and if that data reflects existing biases, the AI can inherit and even amplify them.
Like the Amazon hiring tool example that showed bias against women.
Exactly that kind of thing. It learned from past hiring data, which was predominantly male, and inadvertently started penalizing female applicants. It shows how critical it is to be mindful of the data we use.
So responsible development, transparency, those are key.
Absolutely essential. We need practices that ensure fairness and avoid baking in societal biases.
Okay, so wrapping this up for you, the listener, what's the big picture from artificial intelligence and biological sciences?
I think it's a future where AI acts as a powerful amplifier for our own abilities.
Helping us tackle huge challenges, improving health, enhancing well-being. It's this collaborative dance, playing to both AI's strengths and our unique human strengths.
With human values and critical thinking guiding the process.
Definitely. So here's the thought to leave you with. As this partnership between human intelligence and artificial intelligence continues to evolve, how will it redefine what we even think is possible in the very near future?